Welcome back, dear students, to this last lesson of the abstract data type trees. And today we are going to look at the applications of trees. Now, one, file systems. A file system can be represented as a tree with the topmost directory as the root. So if we take an example like the Windows file system, we will realize that C colon with a forward slash is will be our root. So a file system is sometimes viewed as a tree, not a binary tree, because a directory can have one or many subfolders. So just as a tree. The next, trees are widely used for information storage and retrieval in symbol tables. This is another application of trees. Binary trees are used in compilers to build syntax trees and are used within routers to store routine tables. So those of you that will continue with networking in the university, you will understand what we mean by a routine table and you see how a binary tree is used in this case. Binary search trees can be built to speed up searching. Yes, because remember, a binary search tree is a special type of binary tree where nodes are placed in an order. And now, which particular traversal order gives the nodes of a binary tree in a specific order? Correct, it is the in order. Expression trees, very important. Binary trees are widely used to store algebraic expression. In an expression tree, the leaf node contains operands and the parent node contains operators. Take note, dear students, because you might be given a question in MCQ, a particular expression, then they ask if this was to be represented as on an expression tree, how many leaf nodes are we going to have? And how many parent nodes are we going to have? Take note that the number of operands corresponds to the number of leaf nodes, whereas the number of operators corresponds to the parent nodes. Let us dive in more and understand what we mean by expression trees. Note, when drawing an expression tree, make sure the operator precedence is respected. This is very important. Since from the time we did infix, prefix, and how to convert from one form to the other, and since BODMAS in class 5, till now, we must still respect the operator precedence. Traversing an expression in pre-order generates, it's supposed to be traversing an expression tree. So traversing an expression tree in pre-order generates the prefix notation of the expression. Same for in and post order, which respectively generate the infix and the postfix notation of the expression. Sorry. So that is it. So when you are given an expression, if you can represent it on an expression tree, then performing the pre-order of that expression tree will give you the prefix of the expression. Now, let us take an example. GC June 2023, question 6, sub 1. Consider the arithmetic expression E is equal to A plus B times C divided by D. With respect to arithmetic expressions, define the terms infix, prefix, and postfix. 3 marks. Give the expression E stored as an expression tree in the order read. 2 marks. State in words how you will obtain the expression E in postfix from the expression tree in sub 1b. Give the postfix expression obtained. So that's the sub 1 of question 6. That was for 8 marks, dear students. This is a chapter as logic gates and algorithms. Data structure is another very important chapter when it comes to advanced level computer science 795. Okay. Solution. As we saw in the previous lessons, infix notation is a notation in which the operator is in between the operands. Prefix notation is a notation in which the operator comes before the operand, and postfix notation is a notation in which the operator comes after the operand. As you can see, an example was given. A plus B is our operator in between our operand. Prefix, the operator before the operand, and postfix, the operator after the operand. Now, let us dive into the more important, which is B. When you have this expression E is equal to A plus B times C divided by D, which operation is going to be performed first? Is it A plus B? Is it B times C? Or is it C divided by D? If you said C divided by D, then you are wrong. If you said A plus B, you are still wrong. But if you said B times C, then you are perfectly correct because we have three signs here: plus, the addition, the multiplication, and the division. And we know that multiplication and division have precedence over addition. And now, since multiplication and division have the same precedence, we take the first of them reading from the left, and in this case, it is multiplication. So the first operation I'm performing will be multiplication. And now, how do I generate it in the binary tree? Since I am multiplying B and C, these two, since they are operand as said in this rule, as said here, this will be my nodes. Then they will be connected with this their parent, which is multiplication. So this is what we shall have. The first operation B times C, as you can see. So I am multiplying B and C. That is it I have with the times, as you can see. So the operator is the parent, taking the operand that goes with it in the evaluation as the children, as you can see. So B times C, I have my B times C. After performing this, I need to take the result and I divide by D, as you can see. So after having B times C as I have, I need to take the result and divide by D, which gives me this, as you can see, dear students. So after multiplying, I divide by D. After dividing by D now, I add A to the result. So this is what we shall get. So this is what I have. So this is the expression tree for the question given for 2 marks, dear students. I hope it was not difficult to generate. As you can see, I have my operand A, B, C, and D. I see that A, B, C, and D are all leaf nodes, whereas the operator addition, division, multiplication are the parents. Now, what do we have? For the next part, the C part, the question says, state in words how you will obtain the expression E in postfix from the expression tree. It was already said here. I will traverse the expression tree in post order, meaning left, right, root. This will give me the postfix notation of E perfectly. You don't just say you will traverse in post order. Add more explanation to your answers. This is what values computer science students. Don't just give a vague answer. No, it is true saying I will traverse the expression tree in post order. Yes, you are giving the answer to the question that was being asked. But adding that meaning, or you can say that is left, right, root. You are precising that how the post order is supposed to be done on an expression tree, and it will give you the postfix notation of E. Now let us say give the postfix expression. What do we have? The postfix expression, remember, left, right, root. This is my left because this is the root. I start with the left, which is A. After A now, I have the right. So this is my right here. But the right is a root. So I take the left, which is B. After B, this is the root. I take the right, which is C. Left, right, I take the root, which is multiplication. I'm done with all this left. Then I use the right, which is D, before I take the root, division. Done with the left, done with the left. I take the root, which is multiplication. If you are not understanding this method, you can still use the method that was described in the previous lesson and the alternative method that I described in order to perform the postfix, the infix, and the prefix traversal of a binary tree. Remember that you need, for a postfix operation, the dot need to be at this particular level. Then you draw and you do the traversal so easily. So that is the answer to GC 2023 question 6I. Thanks for watching this video. Do not forget to like, to subscribe, and to share the video in order to increase our community. In our next lesson, we are entering into a new abstract data type, also another non-linear data structure, which is the hash table. The hash table, we shall see how it functions, we shall see its structure, we shall see how to enter values in a hash table. Then we shall see some problems that occurs when we enter data into a hash table. So subscribe to this channel in order not to miss any video that will be uploaded soonest. Thank you very much and see you in the next lesson.